Hello everyone. Hello everyone. My name is Vinay Kumar. Today I'm going to talk about time series method of demand forecasting. Industries from energy and retail to transport and finance today rely on time series forecasting for predicting product demand, resource allocation, financial performance, predictive maintenance, and countless other applications. Despite all the potential of time series forecasting to transfer business models and improve bottom line, many companies have yet to adopt its technologies and the benefits. Let's start with definition and follow with brief overview of applications and methods. Definition. Time series forecasting is a technique for predicting future events by analyzing past trends based on the assumption that the future trends will hold similar to historical trends. Forecasting involves using models fit on historical data to predict future values. Prediction problems, the series applications, time series ranging from forecasting to weather forecasting, in addition that involves factor of uncertainty about future. Time series models have been found to methods of forecasting. Time series forecasting informs all kinds of decisions, business decisions. Some examples: forecasting power demand to decide whether to build another power generation plant in next 5 years. Forecasting call volumes to schedule staffing call center next week. Forecasting inventory requires to stock inventory to meet demand. Forecasting supply and demand for optimize fleet management and other aspects of supply chain. Predicting equipment failures and maintenance requirement to minimize downtime and uphold safety standards. Forecasting infect rates to optimize disease control and outbreak programs. Predicting customer ratings to, to forecasting sales. Depending on the circumstance and on what is being forecasted, forecast can involve different time horizons. How time series forecasting are developed. Time series forecasts are developed based on time series analysis, which compares methods for analyzing time series data to extract meaningful statistics and other characteristics of data. The goal of time series forecasting is to predict a future value of classification at a particular point in the time. Time series forecasting starts with a historical time series. Analysts examine the historical data and check for patterns of time decomposition, such as trends, seasonal patterns, cyclical patterns, and regularity. These patterns help inform data analysts and data scientists about which forecasting algorithm they should use for predictive modeling. The historical time series used for predictive analysis is preparation for forecasting is often referred to as sample data. Sample data is a subset of data that is representative of the entire set of data. Every machine learning or classical forecasting method incorporates some statistical assumptions. Data scientists examine the sample data to understand the statistical attributes. This allows them to determine which model they can choose from and what model processing needs to be applied to avoid violating any assumption of their selection. For example, many times series forecasting algorithms assumes that the time series doesn't exhibit a trend. So before using a forecasting algorithm, the data scientist must apply a variety of statistical tests on their sample data to determine whether or not their data exhibits a trend. If a trend is found, they can elect to either pick or different models or remove the trend from their data through differencing. Differencing is a statistical technique whereby a non-stationary time series or a time series with stationary is transformed into a stationary time series. Many types of machine learning forecasting models require training. Data scientists train time series forecasting models on, on the sample data. Once the model has been trained, the data scientists test out their predictive modeling on forecasting algorithms on additional sample data to determine the accuracy of their model selection and to tweak the parameters of the model to optimize it further. Time series decomposition. Time series data can exhibit a variety of patterns. So it is often helpful to split a time series into components, each representing an underlying pattern category. This is what decomposition models do. The decomposition of time series is a statistical task that deconstructs a time series into several components, each representing into one of the underlying categories of the pattern. When we decompose a time series into components, we think of a time series as a Compromising three components: trend components, seasonal components, and residential or noise. Anything outside the trend of seasonality in the time series. Moving average smoothing is often a first step in time series analyzing and decomposition. The moving average removes some of the stochastic nature of the data and allows you to more easily identify whether or not your data exhibits any trend. Classical decomposition is one of the most popular types of time series decomposition. There are two main types of classical decomposition: decomposition based on rate of change and decomposition based on predictability. Further, decomposition based on rate of change can be either additive or multiplicative decomposition. In additive time series, the three components, trend, seasonality, and residuals, add together to make the time series. An additive model is used when the variations around the trend do not vary with the level of the time series. In multiplicative time series, the three components multiply together to make the time series. The multiplicative model is appropriate if the trend is proportional to the level of time series. Time series regression. Regression models are among the most common types of time series analysis and forecasting techniques. Regression models describe a mathematical relationship between forecasted variable and a single predictor variable. The most well-known regression model is linear model. However, nonlinear regression models are extremely popular. Multiple regression models describe the relationship between a forecasted variable and several predictor variables. Understanding regression models is the basis for understanding more sophisticated time series forecasting methods. Exponential smoothing. Exponential smoothing is the basis for some of the most powerful forecasting methods. Exponential smoothing produces forecasting based on weighted averages of the past observations. In other words, these models produce forecasting most closely resembles recent observation. Exponential smoothing techniques are extremely popular because they can be very effective predictors, can be applied to a wide variety of data and use cases. Common types of exponential smoothing includes single exponential smoothing, SES, double exponential smoothing, DES, and triple exponential smoothing, TS, also known as Hall-Winters method. SES forecasts are weighted averages of the time series itself, while DES forecasting are weighted average of both trend and the time series. Finally, Hall-Winters or TES forecasts are weighted average of the seasonality, trend and time series. The ETS model, referring to explicit modeling of error, trend, seasonality, is another type of exponential smoothing technique. ETS is similar to Hall-Winters but was developed after Hall-Winters. It uses a different optimization technique, different optimization technique for model initialization and overcomes some exotic time esoteric shortcomings of Hall-Winters that exist in relatively uncommon scenarios. In relatively uncommon time series scenarios. Time series determine the appropriate demand forecasting using time series method. I mean, demand forecasting is a very important factor for business to do in the proper way. It is a crucial issue for companies to achieve efficient operations, management planning. Since all organizations will deal with the uncertainty in the future, some error between forecasting and actual demand is to be expected. The purpose of accurate demand forecasting is to minimize the deviation between actual demand and forecasting. Demand forecasting. Forecasting is about predicting future events. Demand forecasting is used to predict the future demand of the company's product and service with the aim to able to fulfill the customer's desire over specified time period, which is done by using the historical data, usually based on demand data. Having good data, good forecasting is crucial for having a effective service, and for manufacturing operations. The general demand forecasting method can be classified into four types, which are qualitative, time series, casual, and simulation. Qualitative forecasting is a forecast which based on instinct, emotions, background, and value systems. Time series forecasting is method that relies on historical data and assumes if the historical data is an indicator to forecast the future, it will be appropriate if the demand pattern is not very significant in nature. Casual forecasting is a method that assumes that the event will be influenced by the current conditions in an environment, such as the state of the economy and interest rate. Simulation forecasting is a method by combining a time series and causal method. This method emulates the consumer decisions that cause humans to arrive at a forecast. Time series method. The forecasting techniques that are examined in simply moving average into the function. That's all. Thank you.